Okay, it is Wendell again, and today what we're looking on is conversion from fractions to decimal. So we want to learn how to convert fractions to decimals. Let us say we don't have our calculators and we need to do that. How do we go about that quickly? Well, there are a number of ways. Let us say we have, let us say we're doing a half. So we want to change half to decimals, right? And then remember the half means 1 divided by 2. All right, so it means 1 divided by 2. So what we're going to do is to set up our long division. Okay, we could do short division, but I'm dealing with long division now. So 2 into the 1. All right, so as you could see, 2, the denominator, will be divided into the numerator. So 1 divided by 2. All right, so we'll put the 2 in here. All right, let me just remove this for a minute. All right, so what we're going to do now is to divide the 2 into the 1. And then if I say 2 into 1, then everybody will say 2 into 1. All right, how many groups of 2 we could get out of 1? Well, technically, if you think about it, all right, it's going to be a rough task. 2 into 1, we can't. All right, so now we're going to have to say, okay, how do we do this? And that is why we're going to convert from fractions to decimal, because 2 into 1 would have meant that we won't be able to get an whole number. We don't have anything else. So we're going to get fraction number now. We're going to get a fraction number, a decimal number, I should say. So we're going to introduce a decimal point. All right. We're going to put a decimal point and then introduce a 0. Like this is a 10, but it's not a 10. Understand? We would understand that it's a 1.0, but we're going to operate on it like it is a 10 because we understand that we're in the decimal world now because we never had any other digit behind that. So we'll work this out that way. So we'll say 2 into 10. So we'll now incorporate all of this as one idea to facilitate our division. So 2 into 10. And I'm not going to put my response over the 1 because remember 2 into 1 we can't. So we're going to have to put the number over the 0 here. So 2 into 10 is 5. Then we multiply 5 2's. We get a so-called 10. We subtract. All right. So it's like we're ignoring the decimal points for now, but we know that the decimal point is there. 10 from 10, we get 0. So this one is finished. All right. Where do I put the decimal point? You just move it up right here. All right. Bam. That's where you put your decimal point. So technically our answer is 0.5. So 2 into 1 is 0.5, right? In other words, how could you divide up 1 into 2 equal parts? Well, 0.5, 0.5 or a half. So you could see what we're dealing with. All right. So a half to decimal is equal to 0.5. And everybody would agree to that, right? Now let us look on some others, right? Let's look at some others. All right, we're looking at dividing. Let us say we have a 3/8, right? So we have 3/8, and we want to know the decimal for 3/8. It's going to be 3 divided by the 8. 3 divided by the 8. So we're looking at 3 into 8. But we can't. Therefore, we're going to introduce a 0 behind the 3 and put our decimal place because now we would realize that 3 divided by 8 will not be an whole number. It's going to be a decimal number. So we're going to have to put a decimal point and then we'll be adding a 0 to facilitate this as a 30 to divide into. So 8 into the 30, all right? 8 into the 30, we get 3 times, and then 3 times 8, that's 24. We subtract. All right, so if we subtract now, 30 minus the 24, we would get 6. Or if you want to say 4 into the 0, you can't, you borrow. All right, so we'd have 4 from the 10, we'd have the 6. All right, thank you. And then now, whenever you're dividing fractions, turning fractions rather into decimal, you try not to get any decimal, any remainder. You continue until it's finished. All right, you continue until it's finished. So here I have a 6. I need to have a 0 when I subtract. All right, and we'll see the cases when we have to stop. But right now, let's see first. I'd have to introduce another 0 and then I take it down. So now we're saying 8 into 60, all right? 8 into 60, and that sounds like 7 times. 7, 8 into 60 is 7 times. 7, 8 is going to give us 56. Let us subtract. We get a 4 when we subtract. I'm looking for a 0. What we're going to do, introduce a 0 and take it down. All right, so 8 into 40, that's a 5, and then 5, 8, we get 40, and there we have 0 when we subtract, and then this is where we stop. So we're looking at, remember, the decimal point here should go back there, so we're looking at 3/8 is the same thing as 0.375 as a decimal, okay? All right, let's look at another one. I think we can take just one more. We're going to take one more. So any number, basically. What if we have a case like this? Because we claim that we need to have this ending. So what if we have 1/3? And I intend to have 1/3 as a decimal. Well, here it is. It's going to be 1 divided by 3. 1 into the 3. No, not my bad. 3 into the 1. Well, we can't. So we're going to introduce decimal. Then we put the 10. So we have 10 now to deal with. So we're going to say, okay, 3 into the 10. Oh, 3 times 3 3s, 9. 10 minus 9, I get 1 again. I have to introduce a 0. Take it down. Because I'm not supposed to get a remainder. 3 into the 10. 3 times 3 3s, 9. Subtract 1, I'm getting 1 again. Oh, it looks like I'm getting the same thing. Add a 0, take it down. 3 into 10. 3 times 3 3s, 9. So you realize that, oh, remainder 1. And this will go on forever. So I'm just going to stop now and show us how do we represent this. We realize that forever we will be getting 0.333. All right, because the decimal point is going to go there. 0.333. And if this is happening forever, then what we could do is just to indicate that by putting a bar over the 3. And this suggests that 1 divided by 3, or 1/3 as a fraction, will be 0.3. The bar over it would indicate that it goes on forever to infinity. All right? Thank you very much for watching, and I'll see you next time.